Hi, welcome to the Calculus 1 lecture series. We are in the unit number 2. We talk about the derivatives. This is the second video we are going to cover for the lecture number 15. We talk about exponential growth and decay. The second video, we are going to focus on how to calculate the interest and depend on how do they provide the interest, how do they compound interest here. Okay, so now let's go ahead and go to our lecture handout. Okay, so in here, let's take a look at what we mean compounding interest. All right, so the compounding interest, that means when we talk about the compoundings, right, that means in here, so if I deposit money, so for example, if I deposit $100, right? So then if I say, let's just assume, my interest is 10%. Of course, nobody pay that much interest anymore. So for example, if you, after 1 year, how much money you earn for interest? 100 times 10 is you earn $10. So you add back. So at here, how much total you have is 110, right? So what do we mean the compounding? That means for the next year, see here, right? Instead of using the 100 as the base, I am going to use this new balance as the 10%. So like for the first year, how much interest do you make? You make $10. But then, so you add the $10 to your principal, so you become 110. So the next year for 10% of the 110, how much you make is you make it $11. So at the end of the next year, so total how much money you have? You have 121. So let's take a look. So for compounding, that means you add the interest again, then you take the 10% again. So how much you have here is $12 and $12.1. As you can see, the interest for each year, they increase. The reason why is because of the compounding, right? So that means you add the interest to your principal. So that's why your principal is getting bigger each period. Okay, that's what we mean the compounding. So for the compounding, we have two formulas here. So the first formula is we say is AT, that means your future value, how much. And then here, this is A0. Okay, that's your principal. Now here, this is 1 plus R, and this is N, and this is NT, okay? So in here, we need to be careful. The R, this is our annual rate. Okay, so this is our annual interest rate. What is N's here? N's here, this is the number of the times you compounding, right? So this is the number of the times you compounding here, all right? And then what is the NT? T is the year, right? Okay, so if you are compounding quarterly, then the N is 4, right? So if you deposit the money for 3 years, you're compounding quarterly, so total NT is 12. That means you calculate your interest 12 times. If you compounding monthly, then what is your N? N is 12. So if T is 2, so how many times you calculate the interest here? So you calculate interest 24 times. Then the next one's here. So this one is just like we talk about the exponential growth. So how about you say, hey, instead of compounding monthly, weekly, or daily, I can compounding hourly, So how about if you continuous compounding, you can compounding to a very, very, every second you compound. So what is the formula here? So this is the formula. AT is equal to A0 ERT here. It looks so similar like what we did before, right? So A0, this is your what? This is your principles, right? just like we said, this is my initial value. And what is this R? This R is what is annual interest rate, right? And what is here T? T is the number of what? T. This one's here, T is number of the years, right? How many years you deposit here. Okay, so it's depend on how do you compound it here. Okay, so let's take a look at some of the example. I also like to show you how to use the TI-84 calculator and make your calculations a little easier. Okay, so now in here we said, suppose $1,000 invested at 4%. Okay, so the A0, this is my principal, is 1,000. So what is my R? R is 4%, right? So 4%, so it's 0.04. Okay, so I want to find the value of the investment after 5 years. You need to read this interest compounding continuously. All right, so now let's try to use the formulas here. So this is the A. So how much money you have if you withdraw? So A5 is equal to your principals, right? So it's 1,000 times 1 plus, what is your interest rate? Is 0.04. So compounding quarterly, so how many times each year you're going to compound it? That's your value of n's, right? How many times quarterly? Is 4, you divide it by 4. So out in the 5 years period, if you're compounding quarterly, so total how many times you calculated your interest? 20. Right? Okay, so now if you put it into your calculator, you will get it is 1220.19. Okay, now the part B, they said, how about if you're compounding continuously? Okay, so remember, right, if you're compounding more frequently, you will get more money, right? So the compounding continuously, that means every second, every minute, I'm compounding my interest. So the compounding continuously is supposed to give you the biggest return, right? So let's see the compounding continuously. So this is A5, right? So it's 1,000 E, R is 0.04. How many years? 5 years. So if you put it into your calculator, what they give you is 1221. So they give you 1221 to the 4 zeros, right? Okay, so that's why it's a little bit more than your compounding quarterly. Okay, so what is the, so let's say, what is the differential equations? The model use compounding quarterly. Remember we said that the model we use is dy dt is equal to the k to the y's, right? So this is just that. So we say, so what is the model we use? So the rate of change is 4%, right? So we know the dA dt, right, is equal to what? Is equal to the 0.04, whatever your initial values, right? And then we know the A0 is 1,000. So that's match exactly what we call is the natural, the natural growth and the natural decay here, okay? So now, okay, so in here, number 8 here, let's take a look at this ones here. So this one's here, this is, we call this the double life here, right? So Eric invests some money in a fund, 5% interest rate continuously, compounding continuously, all right? How long before the Eric's amount going to double? All right, so let's take a look. So we say, I don't know how much Eric deposit. Let's say it's A0. This is the principal Eric deposit. And it's going to yield at 5%, it's 0.05 times T, right? And we say, hey, I'm going to double. So that means after this t, I'm going to have 2 times the amount of your initial value, right? So then you can have a0, you can cancel. So you will say, hey, I will have 2 is equal to e to 0.05 times t. So how to solve for t? Easy. Take the natural log of both sides. So this is 0.05 t. So t is just going to be equal to the natural log of 2.05. So if you put the into the calculator, you will get about 13.86 years. So whatever the amount of money you put in, if this bank is continuously compounding, right? So then it will take you about 13.86 years here. Okay. Okay. Now this is the, how do you use the formula? Try to, calculate. I'm going to show you. Okay. So remember, right? So for the 1,000, the compounding quarterly is 1, 2, 2, 1, 2, 2 zeros, right? So this is 1, 2, 2, 0. This is compounding continuously. Okay, I'm going to show you how to use the TI calculator to do that. And that would be an easy way to, check your homework, right? Okay, so now let's see here. This is my TI calculator. All right. So let's see, how do I do this, all right? Okay, so the first thing is, of course, to turn that on. Okay, so here. Okay, so it's a clear, right? So this is a clear, right? So now, in order to do that, so your TI calculator, you do an app, right? So this is the app. And in the app, you will have a default from the calculator. It's called finance, right? So you choose it, it's a finance. And then you will choose the number 1, TVM solver. So you say in here, right? Okay, so let me clear that. So this, okay, be careful, right? So this capital N is different than the N we talk about. The capital N's here, this is the total, how many times during these 5 years. So we say compounding quarterly. So I know I'm going to calculate my interest, how many times? I'm going to calculate my interest like 20 times, right? So the interest rate, all right, so it's 4%. Look here, they already, all right, so in here, okay, so they already have a percent sign here. So you just input what? 4% here. Okay, so you just input 4% instead of 0.04. And the payments here, so this is the present value, PW, right? Present value, PV. So present value, that means right now you have $1,000, all right? So the way the TI calculators treat these ones here, right now the present value is $1,000. You're going to deposit. So it's kind of like you take out your pocket. So it's a negative. So you put a negative sign here, then you put a 1,000. You see here, the negatives here is because this is your principal, but you take it outside of your pocket, right? And then here, this is the payment. Okay, we just do this initially, right? So it's $1,000 is my principal. I don't do the monthly payment unless we are calculating mortgage or car loan, those things, right? Okay, so we are looking for the present future value. So after 5 years, how much I have here. So let's temporarily put a 0, then later we're going to calculate it. Okay, so in here, okay, so this is the payment per, so this is the payment per year, right? So right now, remember, we only do one payment here. It's my initial principles, right? So it's 1. And what is in here? This is C, that means it's a compounding per year, right? Compounding per year, so you are compounding quarterly. What is here? So it's 4. And then in here, when they give you the interest at the end or the beginning, of course, they give you at the end, right? So you choose the end. Okay, after you choose this one, then you need to go to, you want to find the future values, right? So you want to find the future values here. So you put your cursor into the future values, and then you do a solver. So you do the alpha, the green keys here, you say alpha, then solve is here, right? You say solve. Ha. So like what do they have here? So they will give you, oh, I'm sorry here. So I did a mistake here. So payment, I'm sorry, because you pay, they're going to pay your, they're going to pay your interest, they're going to pay your interest how much? 4 times a year, right? So it's a 4, okay? All right, so let's resolve it, alpha and solve. Oh, wow, its match is 122,019. That's exactly what we saw from the previous. So here, this is how much, how frequently they're going to pay you, that's right? Okay, so now let's take a look. How about for the continuously? How do I do it? Okay, so when you do the continuously, okay, so in here, this is kind of the tricky way. So you keep everything the same, right? And the tricky ways here, the payment is 1 because you don't really, so the payment is 1. So now here, this is 5 years, right? Because the compounding continuously. All right, so interest rate is 4. You still haven't pop, take out, still pay the bank, take the $1,000 outside of your pocket. And this one is the one we want to find. So let's temporarily set 0. So you get a payment once a year, right? Continuously. And how many times you compounding? We say it's a continuously compounding. So that means many, many times. So the way you can trick it, you can just say, oh, so let's put a 1, 0, 0, 0, 0, 0. I compounded this many, many times. Then, in fact, really the number is, is your compounding infinity number of times, right? But of course, I cannot put the infinity. So I just put many, many, like 100 million something. It's the end, right? You still they pay you at the end of the year. Now you go to your future values here, right? Then you do what? You do alpha and solve. So see here, you got exactly what you have by using the formula. So 122140. Okay, so that is the quick way if you want to use your calculator to verify it. So the things you be careful. So now this n is the number of the years because when you do the compounding continuously, it's by years. All right. Okay, and that's it. So if you go back to our worksheet, you see that's what we got exactly the same by using the TI calculator. And so I hope that you learned how to use the TI calculator to help you to do this type of problem. It's pretty easy and handy, right? And you can use to check your answer. Okay, that's it. And that's it for these lectures here. Okay, and it's a very useful skill. We talk about the exponential growth and exponential decays here. Okay, that's it. And I will talk to you and in our next videos here. Okay, bye.